Um, Welcome, everybody. Thank you for coming. We're going to talk about an idea today called what? I think it's on, but maybe I'm not standing close enough to it. Okay. Okay. Is that better? Wait. I'm not humming. Oh, it happens in this room. Oh, okay. Thank you, Jake. Jake is our community fellow today. He's already been so amazingly helpful. It's wonderful. I'm Ted Haberman from Metadata Game Changers, and I wanted to introduce this idea of recuration. And I have a picture that might help you all have a picture that you can remember in your mind. It starts with these two data sets. And if you're at a repository, this is, some colleague has just dropped off two data sets at your repository, and you go through a submission curation process. We talked about this yesterday afternoon, the submission process, and you add in some cases great metadata, in some cases minimum metadata. And usually the goal is discovery. So you want to allow users to discover data sets that are in your repository. So you sort of focus on discovery metadata. This is a slide that I created a while ago for old Mother Hubbard. She was looking in the cupboard for some dog food or some soup, and unfortunately she didn't have any metadata, so she couldn't tell which was which. And this is what it looks like with discovery metadata. But and this is the result of a curation process in a repository, and the curation processes that go on in any repository are super helpful in terms of interacting with the data providers and improving their data sets, improving their metadata, improving accessibility, et cetera, but usually the goal is to get as much as you can get out of the researcher, which many times is just discovery metadata. So after the data set gets curated into the repository, as time starts passing, and there's a number of things that might happen. You might have new metadata elements coming out, new revisions of metadata models. You certainly have papers that might be published using those data that you want to connect to the data sets in the repository. And the thing that we're talking about quite a bit today is these identifiers keep happening. So the identifiers we're going to talk about have many of them have emerged over the last decade or so, but even right now there are new uses, new identifiers coming up, say for instruments, new identifiers merging into DataCite for IGSNs and stuff like that. So identifiers change, and you need a recuration process. And the result of that recuration process is well-identified and well-connected data sets, and data sets that have metadata that's up to date and reflects changes that might have happened. So I want to talk about this in terms of the Dryad repository that some of you probably know about. It's a large, I guess it's not that large. They think it's large, something like 50,000 records or so of data sets that have been accumulated in Dryad over the last 10 years or so. And working with some of you know Danielle Lowenberg. She came to a few ESIP meetings a while ago. She was the project manager for Dryad from CDL, and also John Chudaki. They explained to me what these things called RORs were, and asked if I could help them with that a few years ago. And there's this thing called Crossref that Madison's going to talk about. Nice thing about Crossref is it has journal metadata, metadata for journal articles, and Dryad, one of the most super important things at Dryad since the beginning has been having a DOI for that paper, that connected paper. So those DOIs in Dryad provided a connection into Crossref, and we could use Crossref to get affiliation information for authors, because the original Dryad metadata model did not have authors or affiliations. And the reason for that is because the idea was that you would read this paper and you would get information from that paper, and then you would know who the authors were, and then the data sets were sort of attached. So when Dryad was taken, when the back end of Dryad was taken over by the California Digital Library, the whole metadata model changed and we added these affiliations in. But the critical piece is that we could take advantage of those DOIs and use the connections into Crossref for this affiliation information. The ROAR organizational identifier was just being developed at that time. And that's really what we were going after. We were going after these ROARs that we extracted from the affiliations, and then we put the affiliations back into Dryad, or the identifiers for those affiliations. So adding in the affiliations and adding in the DOIs, the ROARs, are two recreation efforts. And at the same time that Dryad was doing this, the metadata model was evolving, they evolved to the DataCite metadata model. So they could use DataCite, they could connect to DataCite directly, and those ROARs and affiliations and other metadata went into DataCite. So we were grabbing some things from one sort of element of what I call the global research infrastructure, in this case Crossref, putting it into a local repository at Dryad, and then putting it back into another side of the global research infrastructure at DataCite. And this was really the first large-scale implementation for ROAR, and we did ROARs for about 20,000 different organizations, and then ended up with, at that time, something like 100,000 identifiers in their DataCite metadata. And this is sort of the picture, the representative of the infrastructure, in this case, having publications, organizations, and data sets. Crossref also has funder information for some, not enough of their DOIs. Crossref has something on the order right now of something like 150 million DOIs in Crossref. So, and you get an average of 6 authors per each of those. So that's quite a bit, 600 and some million authors, and there's funder information for probably less than 20% of that stuff, but it's growing. So we could use the same strategy to get funder and award information and add that into the DataCite metadata. Okay. And so now we were able to add funders into this picture. And this is, you know, a much richer environment for finding out about things that have been funded. So as you make these improvements, it's also, I was just throwing around some numbers, and they're sort of back of the envelope numbers that I remember or misremember. But so it's really important to be able to measure progress that you make during these efforts. And it's helpful because we're trying to justify this work that we're doing to various people, and they like measurements. So this is a picture that shows, as a function of time, the percentage of Dryad records that have affiliations as blue, and identifiers for those affiliations in red. And obviously you don't get identifiers for all of the organizations, so red's a little bit below. And we'll talk about just the upper plot, because what's important, one of the things you want to know is how well is your recreation working. So what happened at Dryad, which was a great thing, they integrated, and as part of this migration, they integrated ROARs into their user interface. So when you're registering a data set at the beginning of that initial submission process, you can put in a ROAR. And that time period is sort of from this dip. We had a little dip here as we were transitioning systems there. But after that dip, shows the amount of affiliations you get if you're using it in the submission process. So that's sort of our test. We would like to do as well as they're doing when they're getting it directly from during the original curation. And in this case, it shows that, except for the very early days when there were not a lot of DOIs, we're doing about just as well as they're doing with the submission process. So recuration is matching curation in terms of the percentage of results that you're getting. The bottom, the green line, is ORCIDs. in Dryad. And one of the other nice things that ORCID did at this time of the transition, or that Dryad did, is that they instituted ORCIDs as logins for their repository. So if you want to get ORCIDs from in your repository, you just make people log in with them, and then you get them. You know, it's much easier than begging and you know, sending them donuts and stuff like that. So, but this is a recuration process starting to happen, or that needs to happen, and it's called spreading. This is a community. There are communities inside of Dryad, although it's a generalist repository, so it's not like one community. There's a bunch of them, but the same organizations, or in ORCID case, the same people submit things over time. So we can spread ORCIDs. We can find ORCIDs for a person who submits a data set since 2018 or 2019, and we can find data sets that they submitted earlier and spread those ORCIDs through the repository. So that's one of the techniques that we use to try and, in community repositories specifically, or that's where it's most helpful typically, is to be able to find something in the current time and move it into the past, and then bring up those ORCIDs in the back. Another kind of recuration effort, sometimes there's a special effort. I was working with some librarians in Michigan, University of Michigan, or Cornell, and they one of them said, you know, during 1919, I did a bunch of work and put a bunch of ORCIDs into our metadata, and you could see this blip in there in the history. You could see these special projects. So the funding thing that I mentioned earlier was a special project done by Ryan Shirley and Daniela at this time, while working at Dryad, to get funder information. And they were doing that on top of the new database rather than the old database. But so you can see there's a lot of time variation here. This is number of funders, funder IDs, and award numbers. So these are all important numbers. But this is another and of course, funders can't be spread, right? Because there's different awards in the back, but you have to use different techniques to try and find this stuff. So this is a few examples of recreation that we did at Dryad that has been pretty successful in two ways, and also the importance of measuring progress in these efforts, so you can understand what you're achieving and what still is an opportunity for improvement. So today, we're going to have 4 tales of recuration. This is mine. It's done. Madison's going to talk to us about some really cool stuff that's going on at the U.S. Geological Survey with Crossref and DataCite, the two things that we talked about before, and then reports and papers and documents that come from USGS scientists. After that, Bob Dettori is here from NCAR. And NCAR is in the process of recreating DataCite. So one of the things that people do with DataCite is they put in the 5 required fields, which don't include abstract or subject keywords or any identifiers at all, except for the DOI. And they get a DOI back. So that's called the give me the DOI as fast as possible use case. It's not like document my data set very well. So what NCAR is doing now is, and UCAR in the bigger picture, is getting those, trying to get those identifiers, finding them somewhere and getting them into DataCite, which allows DataCite is really the hub of connections between these things. So that's what Bob's going to talk about. And then Aaron Robinson is going to talk about this ongoing curation in field stations. I actually don't know what she's going to talk about. I don't see her very often. But she's going to talk about this idea that metadata changes as a function of time. And you know, we've started out with metadata for things that are static, and you make the metadata, then you move on to the next thing. But actually, what we really need to create well-connected data sets is metadata that evolves as a function of time, and Aaron's going to talk about that. So without further ado, and then we'll have a discussion, hopefully time at the end. If you have like really, really pressing questions, then you might be able to wedge yourself in. But or we can have a discussion at the end. So without further ado, sorry, I'm just learning how to use computers. And somewhere down here in PowerPoint, we go like that. Okay, thank you.
Sorry, I got a screen share is paused. Sorry.
Oh, whoops.
No, it's okay.
Thanks, Jake.
Yeah.
Let's do.
Can we just share the screen? So
Yeah.
have to do the first one?
Yeah.
Cool. Awesome. All right, thank you. Hello, everyone. I'm Madison Langseth, and today I'll be talking about USGS and the ideal data citation workflow. Before I get started, I'd like to recognize my colleagues, Grace Donovan and Kelly Haberstroh, who have been instrumental in the work that I'll be discussing. Now, if I can advance the slides. There we go. Okay. So in this presentation, I'm going to review the ideal data citation workflow and discuss the work that we've been doing to assess and improve how USGS contributes to this workflow. So researchers have been citing scholarly works in their publications for a long time. Only within the last decade or so have we asked them to also cite their data using a digital object identifier. So data citation is the first step to helping us understand the data use and reuse. But researchers alone are not responsible for ensuring that data citations are implemented and used within the scientific community. It really requires a number of stakeholders. So Make Data Count, a global community-led initiative focused on incentivizing data sharing by developing open research data assessment metrics, has outlined the ideal data citation workflow as follows. So first, researchers need to include data citations in their publications according to journal data policies. Second, publishers need to send data citations to Crossref as part of the publication's DOI metadata. Next, repositories should send publication references that they're aware of to DataCite as part of the dataset's DOI metadata. Then Crossref and DataCite need to share the DOI metadata with the research community through APIs such as event data. And finally, the research community can assess metrics related to links between datasets and publications using the Crossref and DataCite APIs. So at USGS, we have the capacity to participate in the first three steps of this workflow. So I'm going to focus on those three for this presentation, and I'm going to start with this first one. So our first question is for our work that we were doing is, are USGS researchers citing their own data? So this idea of like tracking whether researchers are citing data can be rather tricky to answer. But we found that we were fairly well suited to answer it. So starting in 2016, USGS researchers were required to publicly release their data, and these data needed to be assigned a DOI. They needed to be accompanied by a citation, and they needed to be referenced from their associated publication. When USGS researchers acquire a DOI for their data through the USGS DOI tool, they're asked to provide the DOI for the associated publication. And if they do not know the publication DOI at the time of minting the data DOI, they can provide us with an internal tracking number for the publication, and then we have an automated process for fetching the publication DOI once it is known. So through the USGS DOI tool, we're able to retrieve a list of DataCite DOIs and their corresponding publication DOIs. So in theory, these DataCite DOIs should be cited in the corresponding publication. How can we verify that this is the case? All right, so we use two methods for checking publications for data citations. So first, we use the Crossref API to determine if the Crossref DOI metadata for the publication included the DataCite DOI for the data in a references DOI element. I'm saying DOI a lot. Hopefully I'm being clear enough on what I'm talking about. Second, we used XDD, a digital library of over 14 million commercial and open access publications of scientific works, as well as Publing, which is a Python package that sits on top of the XDD API and allows users to find relationships between publications and data. So these two tools allowed us to search the full text of a publication to see if it includes a mention of the DataCite DOI. Okay, so we were only able to find the DataCite DOI in the cross-references for 9% of the 2,700-ish publications in our sample. Now, this low number is partially due to the fact that only 53% of publications in our data set included any references in their cross-ref metadata. And partially due to the fact that many of the publishers who are sending references to cross-ref do not include the DataCite DOI in their cross-ref references, or do not include it in a machine-readable format. While only about half of the publications in our data set were indexed in XDD, we were happy to see that more than 3/4 of those that were indexed had the associated data DOI mentioned in the full text. So that tells us, okay, researchers are saying in their publication, hey, here are the data that I used. Okay, back to this ideal data citation workflow. From our initial assessment, we saw that researchers are sort of doing their part, but we could see that it doesn't seem like publishers are doing a great job of sending data citations as part of the cross-ref DOI metadata. And since USGS, this is where I come from, is the publisher for a large percentage of the publications in our data set, about 45%, that got us wondering if USGS was providing any data citations in our cross-ref metadata. So USGS has been publishing technical reports for over 140 years and recently began implementing XML publishing using the BITS XML document model in the past few years. Only a portion of our technical reports have been made available in XML format so far. However, though the rates of XML publishing kind of continue to increase, USGS has not been sending the references available in the publication XML to Crossref. We are sending associated DataCite DOIs that have been captured in our publication repository metadata as related items in Crossref. So that's like one thing, but it's only like if the author explicitly says, hey, I used these data, can you please make this connection? But we're not sending it as a reference, and we're not sending the full references from the publications themselves. So I reached out to Kelly Haberstroh, who's with the USGS library and is responsible for the USGS Crossref membership. And we devised a plan to update our Crossref metadata. So Kelly confirmed that because we have XML documents for our publications, that it would be relatively easy to extract the references and their DOIs. So I was able to transform the XML references from the publication into the Crossref XML schema that we can use to update the Crossref DOI metadata. So if you enjoy reading XML, I'm sure many people in this room do, you may notice that we are passing both an unstructured citation and the parsed DOI to Crossref. So the parsed DOI is very important for enabling this machine readable connections between data and publications. So our next steps are going to be so this is all very new, happened a couple weeks ago. So our next steps are to run a bulk update of our Crossref metadata for all pre-existing USGS publications that are formatted as XML publications. So as I mentioned, so this is kind of a recent thing. So we started our XML publishing journey around 2019, and we're still working on that process. So we're not yet comprehensively employing XML publishing. So that being said, there are only about like 500 XML publications whose cross-ref metadata we can update. And there's not really a plan to convert historical USGS publications to XML. That being said, 500 publications is better than nothing. So here we go. But we're also then working to incorporate this new transformation code into existing workflows here at USGS so that references from all future USGS XML publications are going to be sent then along with the XML package to Crossref moving forward. Okay, so finally, I'm going to touch briefly on what USGS repositories, data repositories are doing to send publication references to DataCite. So we use Public to mine XDD weekly for mentions of the USGS DataCite DOI prefix 10.5066. When we find a new mention, we store the publication DOI that is referencing the DataCite DOI as a related identifier in the DataCite's DOI metadata. We use the relationship cited by to make this connection. We then display the related citations in the USGS Science Data Catalog, which is our USGS metadata catalog, to enable end users to understand how a particular data set has been used in the scientific literature. Now we know that XDD doesn't contain all USGS authored publications, only about 50%. But this work in combination with recuration of cross-ref metadata by publishers could get us a long way toward a more complete persistent identifier graph and understanding of how research outputs are related. So as we can see in the ideal data citation workflow, there's a heavy emphasis placed on making connections between data and publications. But I would like to propose that we should be also emphasizing connections among data sets and other research artifacts. Perhaps there are other repositories that are already doing this, but I know at USGS we could be doing a lot more. So for example, we require complete scientific metadata in the format of the content standard for digital geospatial metadata or in the ISO 19115 format alongside our data sets. Within those metadata records, authors document source data sets, software, and other publications that were used to create the new data set. But we don't actually mine these scientific metadata for these references. So there's a huge opportunity for us to make more connections across research artifacts by developing workflows to extract these links from larger work citations or cross-reference elements of the scientific metadata and include them in DataCite metadata. So if there are other repositories, like if you were working for a repository that's already kind of incorporated something like this into your workflow, I'd love to hear about your process and kind of how you do that. Likewise, I think there are opportunities to do something similar for software and other research artifacts. However, this seems a bit more challenging to me. I kind of live on the data side of things. And I know that at USGS, standardized metadata requirements for our software release is very minimal and doesn't include an approach for documenting the sources used in the development of the software kind of in any sort of machine readable structured format. Still an opportunity there, see what we could do. With that, thank you. Please do get in touch if you have questions or if you're doing something similar, and I'd love to compare notes. Thank you.
Yeah, I think we're gonna follow the questions with that. I think it's any questions on that. Wow.
It's the left key, right?
Government uses Windows.
All right. So I'm Bob DeTore. I'm from the National Center for Atmospheric Research, and our group there runs the research data archive, or curates the research data archive at NCAR. I'm going to talk about specifically a recuration effort for DataCite metadata that has been triggered by a UCAR-wide. UCAR is our umbrella or organization, a project to connect ORCID IDs with people. But I'm going to start a little bit more generally. The left key. Wait, which one is it?
Yeah.
Oh, down. There we go. All right. Just a little bit generally about what is the RDA and what is our metadata collection and storage strategy, and then lead into the recuration effort. So just quickly, we're a large and diverse collection of geoscience data aimed at weather and climate research, lots of meteorological and oceanographic observations. So think land stations, ships, aircraft, think long temporal ranges, but with data gaps, missing data. And then we have model outputs from climate models and operational weather forecasts. So there think, global coverage, not much missing data, pretty complete, periods of record. We have 720 data sets, over 18.5 million files, and over 6 petabytes of storage. So size-wise, it's a pretty good size archive, but only 720 data sets in the sense that that's how we package many files go into a data set. So 720 is the max number of DOIs that we have. So our strategy has been to create an in-house, basically, collection and storage system. It's really standards agnostic. We created our own XML format because it needed to handle the diversity of our data. Again, regular grids versus irregular observations. But it also makes it easy for us to add new fields on our own schedule. So we can extend our XML schema when we need to add tables and columns to our database and so forth. We don't have to wait for somebody else to update something. But it is informed by the standards. So we might add a new field to our metadata system if it's a requirement of a certain standard that we want to map into. And that gets into what we do is we map into many community standards. So the two in pink are the two standards that we actually push metadata. We push ISO 19139 to the UCAR dataset search because the CCAN instance needs that for metadata harvesting. And we push metadata to DataSite because they're our DOI provider and we want to keep them up to date. But we have an OAI server that can pull, say, GCMD's diff, Dublin core. We embed schema.org's JSON LD in our web pages and so forth. And it's easy for us to add a module for a new standard, if something else comes along that we want to map into. So we have a few tools that we use to curate metadata. A GUI application we call the Metadata Manager. This is what dataset specialists will use to enter the high-level metadata, particularly at the time the dataset is created. Then we have another utility, a Unix-like utility that runs at the time that data files are put into the archive, and it scans the files for what's inside the files themselves. And so we can pull out like temporal range and parameters and things like that. And then the third utility that's important here is this DOI utility. That's what specifically mints DOIs through DataSite and then pushes metadata up to DataSite for the data set. So some of the reasons why we even would recurate metadata, so you get it into the system, right? But why ever go back? Well, in the case of the RDA, we're actually pushing probably 60 years of existence. And so over the course of all those years, there's been lots of system changes. We actually started out with handwritten metadata in notebooks. And at some point it got digitized to flat ASCII text files. And now, of course, it's in structured XML and relational databases. Persistent identifiers didn't always exist. We had and still maybe have folders with hard copy paper documentation and maybe a directory file name on a mass storage system somewhere. And then over time, got on the internet and URLs became our identifiers, and now DOIs, digital object identifiers, are what we assign to our data sets. And then this new effort now to connect authors to ORCID IDs. So, and then there's the one-off updates. You know, you might just be extending the temporal range of a data set or add some new information to an abstract or connect a published work or whatever. So recurating data sites specifically requires executing this DOI utility. As I said, it pushes a new copy of the metadata up to DataSite in their XML format. The metadata manager tool will do that automatically if a DataSite field is updated. So something like the title or the abstract or the authors, those are marked as mapping into DataSite. So if a specialist changes anything in those fields, it will trigger a refresh of DataSite's metadata. And then we can also run the tool manually, say to do a bulk run to upgrade to a new version, for example. Okay, now to the current recuration effort. We're doing this because we want to add ORCID IDs to for dataset authors. Metadata manager has been extended to include this field now as an optional field for an author. And in the process, we're taking the opportunity to upgrade from version 3 to version 4 of DataSite's format. And what this is getting us is, and Madison mentioned this a little bit, the related item property in DataSite's metadata. It allows you to specify, say, a published work that is somehow related to the data set. And this wasn't possible in version 3, or at least not that I know of. But the relation type, how the this work that you want to connect to the data set, that's a requirement. So the metadata manager is extended to require the field. And that's actually going to force recuration of a lot of data sets that don't have that populated yet. And then we're also going to start pushing out geolocation information, which we weren't doing. So bringing it around to connected and open science, like recuration and, you know, persistent identifiers that now are possible that weren't always there. You know, these things facilitate things like data citation and published works. It elevates the data citation to the bibliography from maybe just an acknowledgement somewhere in the text. And that helps with discovery and impact measurement, because metadata services like Crossref and Elsevier can now connect data with published works. And that lets us do things like this. We can say this data set has been cited 76 times. We can show you a bibliography of all the works that cited the data set. Other researchers can come here, find out, you know, what work has already been done with this data set, you know, new ideas type of thing, reuse is being facilitated here. And then we can also do metrics. We can show our top 20 most cited data sets. We can also show citations by year for the entire archive, by data set. We can use these metrics to decide, you know, if data sets are still relevant, you know, how we see the citation statistics change over time. So just kind of to summarize it, you know, our in-house development has made it easy for us to add new fields when we want to. We can map into many of the widely used standards right now, and tools can force recuration when we need them to. And recuration can apply to all data sets or just a single data set. But these major change points are an opportunity, like to upgrade to a new version, or even maybe create a map into a new standard. Makes you think about things, you know, type of thing. So I was going to try a demo. Do you think that will work, or should I just run through the slides?
Do the demo.
Do the demo? All right. How would I do it on here? I just need a browser. And then cross fingers.
You're a brave man for a live demo.
Exactly.
You can see that on
And I
there.
think I can run through this pretty quickly.
All right, should be good to go.
All right. So RDA.ucar.edu.
The green tab on the sharing.
Oh, yes. It, there, did it? Is that what you wanted me to do? Okay, good. All right. You just need to get,
I can say it on the board.
okay, cool. You just get signed in here real quick. Yeah, I have so many things. Yeah, there we go. I'm gonna go to the dashboard and I'm gonna bring up the metadata manager here. So I'm actually gonna go into a data set and what I want to do is add the ORCID ID for an author. So it's running through some checks here, but it's going to come up here in a minute. Not a minute, hopefully. Okay, so normally this would open up with all these sections collapse, but you can see there are a couple problems that the tool is going to force me to fix before I can do what I really want to do, which is add the ORCID ID. So real quick, like here, there's a broken link in here. So I need to go in and I'm just going to remove this because I know this page doesn't exist anymore. So good, I cleared that problem. Here's what I talked about with the related item and data site. Now we have this published work. Here, let me open this up. This journal article that is connected to the data set, and it doesn't have a relationship to the data set because this is new in version 4. So I'm going to edit the reference. And up here at the top, the relationship, in this case, the data set is described by this publication. It's actually the data paper. So I'm going to choose that, save the change, and now that should be good. Good. All right, now what I really wanted to do was add an ORCID ID for Suru. She's the lead author on this paper. So what I'm going to do is run. Oh, I know what I want to do real quick too. I was going to show in data site. Here, let's see. How do I? Can I move this?
The little green thing that you're requesting earlier, you can grab that.
Oh, cool. There we go. I just need to open up a new tab. I need the DOI from this data set. So I'm going to run over here to, oh, how do I copy that? I hope it's this key. Nope. Control C will do it.
Yeah, it wasn't like do it. She didn't say do a demo on a different operating system.
Exactly. That's right. That's right. Exactly. Oh, I already opened a data site. Oh, well, anyways, here, let's move this down. No, yeah, that's all right. Okay. So I'm gonna go to their search tool here, drop in that DOI. And I wanted to show this real quick because then you're going to see what happens afterwards. So that's our, no, that's not what I wanted to do. Sorry. What I wanted to do is here, download the metadata. That's what I want to do. Data site XML. I hope this is okay. I hope I can get back to it. Okay, because I want to open up that. Let's see what it's going to do. If I can open this. Can I? No, I don't want to open it in terminal. I want to open this with the text editor.
Show the data site JSON instead of the data site XML. It'll still basically.
Is that a better option? Okay, let me do that. Yeah, okay. This is good. This will work. So this is where you can see. Oh. You can see we're sending, well, if this was the XML, you would see the version 3 schema, but this is version 3. So you can see none of the authors have ORCID IDs. And we're not sending any geolocation information, and there's no related items in here. It's empty at the bottom. So that's what I really wanted to show there before I change this data set. Okay, so back here, I'm going to go to orchidid.org. No, I don't want to sign in. I just want to. Let's do this. I just want to do a search here. Yep, here we go. Suranjana, if I can spell it. There we go. Okay, so here's her ORCID ID, and I'm confident that this is her. So I'm going to pick up her ORCID ID. Yeah, maybe I can do it this way. No, see, I don't want all that other stuff. Yeah, all right. Let's try this. I'm going to paste it in here, and I'm just going to eliminate all that. There we go. All right, ORCID ID's in. Update person author. Oops. Close this field. Oh, you can see that it attached it to her name, by the way. Close this field. I'm ready to commit the changes. We are hopefully going to see ESIP demo, if I could spell. And we should see a series of green check marks. So the metadata manager is now going through a bunch of checks. It's putting information into the database. It's creating the XML format, validating it against our schema, populating the database with the fields that create our dataset homepage, and at the very end, it uploaded. You can see the data site metadata were successfully updated. So if that's true, we should see, and I shouldn't have closed that other page, dang it. I need the DOI again. Okay, back to data site. Oh, I always do that. I always click on that bottom one for some reason. There we go.
Oh my gosh, her name lights up.
Did it? Actually, I didn't. Here, I'll go back. I didn't notice that before. Oh, it does. Yeah. Very. I hadn't noticed that before. Oops. Download. Come on. There we go. Okay. So you can see now her ORCID ID, it has been attached. Yeah. Very cool. And there are lots of authors for this. I don't know. This has put me over the top. Not really. Let's see. Down at the bottom, you can see geolocations. Here it is. It's a global data set. And you can see now this related item has been added in. It's where does it show it? The related item type is a data paper, and the relation type is described by. So we basically did a live update, changed data set, pushed version 4 now to data site, and that's it. So we're done. Trying to close all these tabs. And let me just get logged out of here.
You don't want us updating your metadata?
Yeah, kinda not. There we go. All right. I'm done. So, oh yeah, that's it. So
I'm not really sure I know how to follow that. Live updating of data site metadata to data site is pretty amazing. Hi, everybody. I'm Erin Robinson. I work with Ted at Metadata Game Changers. And today, I think,
Just gonna move that
Okay.
so it's not right in the middle.
I thought let me just touch it for, let's just see what happens.
Click a little more.
Yeah.
Hide floating meeting controls right there. About middle way down.
Yeah. Hide floating. Is there anything interesting in that chat?
There is, but I can monitor.
Okay. Great. So I'm Erin Robinson. I am going to talk today about project metadata and ongoing recreation for a project that I'm part of, the Fair Island Project. Fair, the acronym Findable, Accessible, Interoperable, Reusable. And this is in collaboration with my co-authors at CDL. So it's fun to see CDL, the California Digital Library, woven through some of these talks. Neil Davies, who is the field station director at the Gump South Pacific Research Station, and that's affiliated with UC Berkeley. And then the data site team led by Matt Buys. So, okay. So I wanted to give a little bit of context for what we're dealing with, because we're starting at a different point in the research data lifecycle. So a lot of what we've heard already has been around repositories doing recuration of data that they manage. But I'm moving us back to the field station where research teams are launching to collect data that will later go to repositories. And we think of this as the place-based problem, where data and samples and information gets collected in one place and then it gets separated from that place and loses the links. And really it loses the links to the field stations and to the places that the field stations are situated. And when that happens, one thing that happens to the field station is that it's really hard for them to articulate their value and explain how important they are. I think the other important thing, and we heard this from Alexis earlier at lunch, is that future people really struggle to build on top of existing work if they don't know what's already been done there. So this is the problem that we're trying to address with project metadata. And it also is the vision for this Fair Island project, which is to develop both policies and technical infrastructure for a place to bring things back to the place. So the place that I'm talking about is really a fortunate place to visit, and also a really vulnerable place. We've talked a lot about climate through this meeting. And so the field stations that I work with are the Gump South Pacific Research Station that's on Moorea, and then Teddy Aroa has an eco station, which is a privately held station. Both of these are in the South Pacific. And I mentioned to Neil Davies, I'm really fortunate to have a collaborator who is on the ground and really willing to experiment with different kinds of data management activities. So this is just a quick view of those two stations. And the one that we're going to talk about today is the Teddy Aroa Eco Station primarily. But taking a step back, we've been doing some experimentation in the Fair Island project. And so the first case I'm going to show you is based on the Moorea Biocode, which was a project that ran in the mid-2000s. And it was a large-scale project funded by the Moore Foundation. It had 11 teams, and they were sampling on Moorea, which I just showed a quick picture of. And one of the interesting things that they did was that they used a field information management system, and they documented all of the samples that they collected. And that's made it possible for me to do a retrospective look at what it might look like to recurate this project. And because we were partnering with the California Digital Library, we decided that we would try to do this with data management plans first. So our initial attempt was that people coming to a field station would submit an application, and maybe I can just step forward through this. This is a bit about the project. But they would submit an application through a system that the UC, University of California Natural Reserve System uses, called RAMS, the Reservation and Application Management System. So our thought was that they would submit this application, which they do, to gain access to the site. And you can see that it has a project title, it has an abstract. And so from that, we would create a data management plan. And that would give it a DOI. So we created this DMP and it really acted as a placeholder for adding identifiers. So you can see that I did this recuration by hand and added all of these orchids for all of these people. I went through the same process that Rob just went through of going to ORCID, looking up these names, adding them to this form, and added these additional metadata from the application. It also has the funder. Ted talked about funder identifications. And because we were using a California Digital Library tool, it also included RORs when people had organizations specified. So what this gave us was a DataCite metadata record. And then I also went through and did some additional recuration and updating where I went and looked for all of the references that I could find for Maria Biocode. And one of the reasons that we use this project, one, it was large, two, it was a long time ago. And because it was a long time ago, it gave us the time to have additional publications come out about it so that we could see all of how all of these things might hang together. Because for a new project at a field station, they haven't had time to publish yet. And so this also shows you some of the data sets that were affiliated with that project. So there were 3 data sets. And so together, this gives us one initial look at a PID graph. And this little GIF shows the people, the organization that's attached. So we're starting to see this link to the field station, the funders, the publications are evolving. And this is an abstract representation of how a PID graph for a given project would evolve over time. You can just see it sort of growing over time. And so really what this initial case study showed us was that having structured metadata and structured DataCite metadata that included PIDs and could be updated was really important to us. But one of the things that we struggled with was that data management plans weren't really the right kind of DataCite metadata. And so we tried using DMPs in this non-traditional part of the life cycle. And what we found was that research teams coming to the field station, they might already have a DMP or they might be funded by many funders and have different DMPs. So it just wasn't quite the right fit. The DMP citation lists the creator of the DMP and not the team doing the work. So the citation was a little bit off for the project. And like I mentioned, there might be multiple funders for a single application, and we couldn't deal with multiple funders in the DMP tool as we were using it. And finally, the RAMS application includes a lot more detail about the project than just the research outputs. And so what we really needed was project metadata. And so that leads me to the second case study, which is where we'll talk about project identifiers. And I'm really grateful to both Madison and Rob for showing you DataCite and XML, metadata in its ugly form, because this is where we're going. So we, with the data management, the DMP tool, we already had DataCite metadata. And so it had a resource type of data management plan. And we were able to just change to change the resource type from data management plan to project, and the resource type general to other, and migrate. So a lot of what we were already doing was building on this existing global research infrastructure, and the metadata schema did not change, and we just changed types. I also just want to note here that we're not alone in this idea of having projects as a DataCite DOI or DataCite metadata. And Ted wrote a blog recently about project metadata in DataCite, and there are over 100,000 DataCite records that are using resource type project. So when you're wanting to cite a project, there is precedent for doing that this way. So I feel like my thunder was already stolen, because what I wanted to point out here is in our project metadata, just like we saw with Rob, we have the ORCID here for a person, and we also have the RORs for their organization. And it allows us with those 2 identifiers to see the connections in the DataCite commons that Rob was showing. So if we look at, say, the Smithsonian, we'll see this project. If we look at Chris Meyer's page, we'll see this project. And those connections are being made through this metadata record and through this project. And when I was so delighted when Rob's blue, the name that he had linked came up here. You can see here, we have the creators of the project. And what's important there is then that the creators show up in this citation. So what we're giving is we're giving people a way to cite their own project so that it shows up in the references. And if it gets passed in the references for future downstream publications, then we'll start to see this full cycle loop come back of linking papers, code, anything that has cross-ref references that are moving along with it could be linked together because we have a citation. So this is my big hope, that we'll see field station research teams coming to field stations, citing their own projects in their papers, and other outputs. And so one other way, so we mentioned this place-based problem when I was setting up this talk, and one of the things that often gets left out of references and of acknowledgements is the field station. And so field stations are really important when people are applying and trying to come and collect the data. And then there's often a long temporal lag from when they collect the data to when they analyze the data and when they publish the data. And so sometimes the field station either gets left out completely or it doesn't, it's acknowledged in non-standard ways. And so in this project metadata, we've included this contributor type sponsor and included the field station, and we have a ROR for the field station. And so we are advocating for field stations and other facilities to make sure that they have a ROR so that they can also be included in this way. And that this is again a little snapshot of the contributors and being able to see the Teddy Aroa EcoStation is showing up in the DataCite Commons page as a sponsor. And so what this gives us is this ability to continue to grow the PID graph. And so this is one small example of 4 projects, the pink dots, and they're affiliated with 2 research, 2 field stations. And they also have we can have child projects. So the pink dots are child projects, and then this island sustainability program is more of a parent project. So we can see these relationships building up over time. And then the last thing I want to touch on is, actually there's maybe two things. One is many of you are familiar with the CARE principles, and local context is an infrastructure that's beginning to help us implement CARE, which is the connection to the local and indigenous communities. And so what we see with place-based research is that they are connected and aware of the local communities that they are part of. And so local context has a way of research teams providing a notice, and then local communities, local and indigenous communities can provide labels and guidance back for what's appropriate. And so here I'm showing an example of the metadata for a local context notice that can be included in the project. And the other thing I want to mention here is that we are trying to use the project metadata to do as many steps for the researcher as possible, so they wouldn't have to enter metadata over and over again. Like, they don't have to do this again for a notice. We would use our same information. And because we have this included in the metadata for the project, then we also get this little badge here that shows you that there's a local context notice. And so this is actually the first example of a local context notice in DataCite Commons, and it's just a demonstration of what's possible here. So we're excited to keep going with that. And then the last thing I want to mention is the related identifiers, and we've already seen this in both Rob and Madison's presentations, so I don't need to dwell here. But what we're really interested in is linking the project to its related identifiers like samples. And so this is an example of a sample, but all of this is really to grow this graph of linking the project to its permits, like a notice, to protocols, to data management plans, to the samples, and then to the downstream data sets and papers that it's part of, as well as back to the field station and to the researchers and organizations that are all doing this work. And so just to close out, this is because we've done this experiment for Teddy Aroa for the applications. We translated 91 applications that came through RAMs into project metadata. And so this is a snapshot of the data site commons. And this is showing, just a few indicators of number of projects over time. And so you can then start to explore this on your own if you're interested. So in summary, we built on the global research infrastructure. There was really not a lot of new development that needed to happen to make all of what I just showed you possible. Both DMP IDs and project IDs use the data site schema. That was something that I emphasized earlier in this talk. And they were both minted with EasyID, which is a California Digital Library tool. So the switch itself was very easy, sort of all things considered. And then what we really are, I think, excited about seeing and continuing to explore is that this idea of project metadata, adding identifiers over time. So this idea of recuration and also the idea of the evolution of metadata over time. And we're really looking forward to continuing to experiment and prove out the local context work and this connection, making this connection real between the notices and the labels for biocultural resources in particular. And I think that's where I want to leave it. We have a poster tonight if you want to talk more about this. I'm super excited about it and really grateful to be part of this session and looking forward to the conversation.
Hang on for a second. Some button here. I wanted to thank you so much to Madison and Bob and Aaron for those talks. And we're going to get to go to questions right now, but we are right on time. So I have to talk a little bit more to slow us down. But I wanted to mention this because it's something that Bob showed, and let's see, microphone. Oh, there you go. Just for a second. And Aaron showed it, and it's called the Data Site Commons. And I wanted to just point out some things that people here may not know about this. But so usually when we go to a search thing like this, we put something into a search thing and we're searching some repository. But in this case, the Data Site Commons it's being developed jointly by DataSite and ORCID and Crossref. Most of the development's going on at DataSite, but it's an interface originally conceived and developed by Martin Fenner, who was the technical lead at DataSite during most of its formative time. And it's really, you can put in a DOI like we saw. You can also put it in an ORCID for a person, or you can put it in a ROR for an organization, or you can put in a name of a repository or a ROR for a repository. And this interface is actually searching the DataSite, which is 45 million things, Crossref, which is 150 million things, ORCID, which is 800,000 things. And so this is really an interface to what Aaron mentioned as the PID graph, sort of the graph that holds together all or connects together all of these resources. And it's also studying, Madison mentioned event data. So event data is a data stream that was created by Crossref originally. And it sort of went away for a little bit, but now it's coming back. So event data is an ongoing data stream that's constructed from any URLs or any resources on the web that mention a DOI. So it could be a tweet, it could be a Facebook post or a whatever it's called now. So event data is all those other things, plus events that include DOIs. And this is also an interface on top of event data. And the fact that Bob sort of did this demo, which was amazing and wonderful, and that you heard Aaron got excited when the name, like when that name. Oh, here, yeah. So this is Neil, and California Digital Library has a ROR. So these and in Bob's case, this thing showed up sort of instantaneously. So he added that ORCID into a pile of metadata that includes 200 million things plus event data, which is also very large. And it showed up sort of instantaneously, like here, like he was running the server on his laptop. So this, some people remember, how many people remember Alta Vista? Okay, so Alta Vista was the search engine. It got invented and we thought it was really cool. And it was like faster than Netscape or whatever, what, you know, and Data Commons, I think of as sort of the Alta Vista of searching the PID graph. It's an amazing tool. It brings a lot of things together, but it's only going to get better. And it used to be sort of, people would say, yeah, I really like the, like, for instance, for XDD that Madison mentioned is also looking at event data. And there was a statement made in their website or something about how the API was sort of a dog, you know, sort of slow. And Madison saying, yeah, that's right. But Aaron and I have been working with it to try and see these relationships, and it's really starting to work much better and to go much faster. And we just saw a real time install of one, you know, 17 character ORCID somewhere in that pile of 200 million things, and it showed up right away. So the PID graph and the data site commons is really, I think, an important tool to help us try and understand what connections look like. And there's a few other things that are like that, like the research graph that Australia is working on. You can, you know, researchgraph.org or whatever it is, or things like connected papers. They're really, we're in a change of discovery paradigm from putting in a text string or putting in a geographic box or something like that, to using connections between things to discover things instead of searching for things, or in addition to searching for things. And these examples, the data site commons, connected papers is an amazing thing. And the research graph is another. So, you know, for people like Adam, who's sitting back here, he's sitting there, finally Ted is saying something good about graphs. You know, there's really, it's starting to work. And a lot of people in Eves have been, you know, sort of fundamental in pushing that foundation. But anyway, with that, I just wanted to mention, because I think data site commons is really pretty amazing. But anyway, are there any questions?
We also have some
Uh,
time to-
Does someone want to run it? Yeah, no,
I have two questions that are very different from one another. So one is, as someone who does research, what I would love to be able to do is search for co-occurrences. So I might have a data set that I'm particularly interested in. I want to know what other data sets people have used with it. Or I might be in a situation where I want to use two data sets and I'm looking for methodologies to make that people have used to do the linkage process for those two data sets. And maybe that's obvious and it's already implemented here, but that would be a really useful set of functionality. And I'm sure there are other examples of that. And then the other piece is, I was struck by the demo, the NCAR demo. There are a lot of organizations that have metadata utilities that they use to curate their in-house metadata. And it strikes me that there's got to be opportunities for collaboration across those tool sets, whether it be open source component libraries or shared workflows, or I'm not sure where the suite of collaborations are, but I know, you know, I'm beginning to see some evidence that different federal agencies are beginning to say, hey, let's start consolidating our tool sets here. Maybe you've seen that at USGS, I don't know.
I think those, I think that you had two comments that were sort of not related to each other, but I'm not sure that they're answers. I think or that they're questions in terms of the co-used. I mean, Madison is working, and we're also working to try and get connections between papers and data sets. And if those two data sets are used in a paper or in a project or in anything that you can connect to with DataCite, then I think you have a chance of trying to find those two papers together. I'm actually doing a project right now with PAR, the public access repository at NSF. And their Chorus, which is a tool on top of this stuff, has found awards and DOIs that have multiple data sets associated with them. So the start date is August 1st. So let's talk on like the 3rd or the 4th, and we'll see if we've made any progress. And then the tool set, there was a discussion yesterday in the sustainability session about co-evolving some of those tools. And I think it also fits with what I said about this as a search discovery tool across four very large data sources. So I think that would be sort of my response to both those comments. That obviously I think they're both great and directions we should be moving. And there are some indicators that we're making that progress. And the related items that actually everybody was talking about related items or related identifiers in the DataCite schema or Crossref or Works and ORCID or whatever. All these making these connections is getting those data sets connected to the papers or connected to the project metadata records is really the first step. And that's why identifiers are so important. Yeah.
Okay, I have a real question and a comment.
Well, those are definitely real. They were real, they were real comments already, but we'll take a real question.
Okay, so do you know WMO is launching an effort or relaunching an effort called WIS2, WIS2, which is kind of like what you guys doing, but at a different level. Because they're definitely not as specific as what Aaron just showed. The first question, do you know, yes or no, do you know this effort?
No, I don't know this effort.
I think maybe they can learn a few things from here, or you may learn a few things from them too. I can get you connected to the to the guy.
Yeah, yep. Yeah, I mean, the WMO is very similar to RDA. By the way, that is not the Research Data Alliance. It's the Research Data Archive at NCAR, by the way. So if you were confused, but it's very similar kinds of data sets that Bob was talking about at NCAR that, many of them are shared by WMO, but.
Yeah, I have a comment about what Madison did. I think on the other side, so on the other side of the application, what you did is people keep saying the user don't know how to use the data or couldn't access the data or stuff like that. Part of the problem is the user problem. Just like when I first try to order something in the Italian restaurant, I don't know what to order. That's my problem. That's not a restaurant problem. So what you did was show people how the data were used before, and then people can, if people pay attention to read the paper, they will learn. Thank you.
Any other comments, unreal or real questions?
I have some online.
Oh, great. Online question. Hang on for a second, Jonathan. Online question, shoot.
I put all three of them in the chat if you want to just read them. Or if they want to just respond in the chat, that would be efficient.
That would be efficient. If only I knew how to click on a mouse. Chat instead.
I could read them for you if you wish.
Question number 1 for Bob. Are the codes for the curation tools available online? Sure. Or who's got the micro? Oh, the mic. Yeah. Okay. Yeah.
All right. I'll just, the answer is yes. They're in GitHub. The question that I don't know the answer to, though, is if that's a private NCAR archive or not. But either way, they could be put into a public archive. There's no reason they can't be. That might require a little bit of sanitization here and there. But that's something I'll check into. And if they're not in a public archive, I'll get them into a public archive.
What would the name be, or how would I search for that?
Send me an email.
Yeah, I was gonna say, send me an email.
I don't know your email. I don't know who's talking.
Yeah, it's Dattore, DATTORE @ucar.edu.
Thank you.
And Rebecca, we can also connect you. So Rebecca, this is Erin. I think I actually originally was really excited about ROARs because of wanting to have identifiers for working groups. And I think this doesn't quite work. So ESIP has a ROAR. And I think that what we could do right now with what I showed was think about project citations, and maybe we would say that working groups are projects. That might work, and give them a DOI for that. And we could have people affiliated with those projects. And then ESIP would also be attached as a sponsor. So I think you're spot on that what I showed for field stations is also highly relevant for how we might give credit for other kinds of organizations that do this sort of work. And also, so that's, I think, let's keep talking on that, but that's a great idea. And then does DataSite charge for hosting the page that I showed on my slide before the summary? No, the DataSite Commons page is free and will be free forever. So that's a free resource that anybody can use. But
Thanks. How do I keep in touch?
I'll follow up with you. I can find you.
Okay, thanks.
Thanks for being here virtually too, and thanks for speaking up.
Jonathan.
Okay, I have a imaginary question. So I was looking at the relationships in that you submit to DataSite, and there's a resource type, and so I understand you're submitting this information using some sort of hierarchical metadata format, but then, or maybe not, I don't know. Or are you using triples to submit it? And then, because on the other end, it sounds like DataSite is managing a graph, which is triples based.
Is managing.
The graph.
Yeah.
You're talking about a PID graph. So it seems like it'd be useful to manage that natively in the source repository, like a USGS, as a graph rather than a component of metadata.
Right. We showed two examples, DataSite in XML and DataSite in JSON. You can submit metadata to DataSite in either one of those, both structured formats. There is no current plan to evolve DataSite's backend to a graph, but the PID graph is actually a triple store. So the PID graph is pulled from a number of different places and then structured into that triple store. The research graph that I mentioned in Australia is implemented on top of a graph database, Neo4j. So I think that graph databases are starting to make it into the big repositories. And I think it would be interesting to think about DataSite as a graph as well.
Yeah, because I think there's a good use case, like Tom Hanks was an actor in said movie and so on. So you have multiple different kinds of relationships. You have multiple ways Tom Hanks is, he's
Right.
has a role and whatever. So you're dealing with the same issues with the orc IDs, like were they the data submitter or the author of a publication?
Right.
And I think I saw in your talk, you're pulling the authors from Crossref, but you don't really know if they are the data set authors. They were the author of a publication.
Right.
So that's an assumption we make, which you could resolve if you had a triple store.
Right. Yeah, you're perfectly, completely correct that in that Dryad work, we were picking paper authors instead of data set authors. And I think that assumption is probably, the assumption that they're the same is probably okay in a lot of cases. But a lot of times in DataCite, you see just one author out of a, or Dryad is another example of this, where you have data sets and you have papers. And the data set only has one author and the paper has 12. And does that mean that only one author created the data, or does it mean that the author that put the data set into Dryad really didn't want to try and find identifiers for all 12 or 11 of his co-authors or her co-authors and put them in? So anyway, yeah. Let's see, is there anything else online? Okay, Rebecca, we got Rebecca's email. Madison.
So Aaron, thanks for showing the local context and the notices, because I've heard of that before, but it was very abstract. And I had never seen like, how do you actually implement that? So that was really helpful to see. And sounds like that, if you said that was the first instance in DataCite?
We took the DataCite guidance. So DataCite has some example, like an example of how to do this, and that's what we've used in our first record.
Okay, so my question then is, what does it look like once there are labels provided?
I don't know. I think Margaret and maybe others are doing some work with implementing care. I've been having a few conversations with Leslie Wyborn, and I think we're interested in having an unconference session tomorrow on what care implementation might look like in metadata records. But I only know, so from the scientist side, scientists submit notices, but then the local communities gives labels back. And how, one thing we didn't talk about today was how metadata flows with things downstream. And so, we would want the notice to flow to the sample metadata, and then the label, I think, would come back there, but that's something that I hope in 6 months or so we have a better idea. And if somebody else has done this already, I'm really curious to hear about it too. Margaret, I don't know if there's anything you're doing.
Figured out specifically about care.
We haven't figured out where in the metadata that those records would go and what they specifically are, but it would be great for that to be some kind of a outcome of your unconference that we start working on that.
Is there one more hand?
Okay, so yes, no. If you have questions that come up in your mind sometime between now and this evening, a shameless promotion of a poster that we're gonna have this evening on this idea of project metadata and DataCite. And any other comments here?
Really grateful you all showed up.
Yeah, thank you. Okay. And thanks to Jake also for making it go smoothly.
Thank you, sir. Thank you, sir.
All right.